Today's lesson we'll be talking about angle measure to start our chapter 6 discussion of trigonometry. First we need to define some terms, things that you probably already remember from geometry, but some things or some words we'll use that you didn't use in geometry before. So first definition is an angle. Angle is made up of two rays conjoined by a vertex. Okay, so it looks like this, where you got a vertex right there, and then two rays coming from that vertex. The initial side of your angle is the ray where we begin the measurement of the angle. So if you look at our pictures down below, this side that's always going to be going straight, going out to the right from our dot, is always going to be the initial side. The terminal side is the ray where we end our measurement. So if we go counterclockwise, this picture on the left would be our terminal side, the one going up, and for our picture on the right, the terminal side is on the bottom. Okay. Now, the difference between these two angles is that when we go in a counterclockwise direction, we have a positive angle. Okay. If we go in a clockwise direction, we have a negative angle. Okay. So that's something that you want to remember. Angles can be measured in both degrees, which is something that we're used to seeing, and in radians. Radians are going to be values that are represented with the value of pi incorporated with it. So we'll do some examples where we switch back and forth on this. Okay, so here I want to be able to convert degrees from radians, and then that means that I need to multiply my radian measurement by 180 over pi. Okay, to get from radians to, or get 2 radians from degrees, I need to multiply by pi over 180. Now you're probably wondering, where does that measurement come from? So if you think about a circle, okay, if I was starting from the center of that circle and going, let's say, remember this is my initial side, and I go all the way around in degrees, that would be 360 degrees. Okay. Now let's also say that the radius is 1. Okay. Can you tell me what the circumference is of this circle? If you remember our formula for circumference, it'd be 2 pi r. So if the radius is 1, that means the distance around our circle is 2 pi. Okay? So that's the same as going 360. So this is the degree measurement for a circle all the way around. This is the radian measurement of the distance around a circle. Okay? So then using that ratio between those two, we can say 360 over 2 pi. Okay? And because they both have a 2 in common, we can reduce them both by 2, which gives us 180 over pi. Okay? So going back, now I want to be able to convert 45 degrees to radians. So like it says, I want to go to radians. So to do that, I need to look at the one to go to radians. So from degrees, so I'm starting with degrees, so I need to use pi over 180. So I'm going to take 45 degrees, multiply by pi over 180, and then from there I need to be able to reduce, so I can cross cancel at this point. 45 goes into 180 4 times. Okay, so then multiplying across, I get pi over 4 radians. Okay? Now, anytime you have radians, you should have pi in the end. So if I want radians, pi should be in the numerator. If I want to get rid of radians and make it degrees, pi should be in the denominator, because then I'm cross cancel. Like this one, I have 2 pi over 3 radians, and I want to go to degrees. So I would take 2 pi over 3 times 180 over pi. So now, notice, pi's go away. I can reduce my 180 and 3, because 3 goes into 180 60 times. So then now, I have 2 times 60, and that gives me 120 degrees. Okay? So that's kind of how you convert one to the other. Now, before we were talking about an angle and how it was drawn with an initial side and a terminal side. Remember this is the initial side, and then this would be your terminal side. Okay, so looking at this one, this would be your angle measurement, and that could be in degrees or radians. So now all of this together is considered standard position. So when your initial side is drawn in the your angle is drawn in the xy plane, and the vertex is at the origin, the initial side is at the positive x-axis. Like I said, it's going to the right, or opening to the right. So this is how we'll normally draw our angles, because this leads into another thing that we'll talk about later. Okay? Now, something else to consider is that if we have two angles that are in standard position, so the vertex is at the origin, the initial side is at or lies on the positive x-axis, then we can have two angles that are coterminal if their sides coincide, or their terminal sides end up at the same spot. Okay? So looking at this first one, we have an angle that goes all the way around into the fourth quadrant. So remember, from geometry, first, second, third, and fourth quadrants. And so it lands at a certain degree angle, but on the one on the right, we go around not just once but twice, but we end up at the same spot. So these two angles are coterminal because their ending, or their terminal sides, are at the same location in the fourth quadrant. Okay? Even though they have different degree angles, they're both multiples of 360, or sorry, not multiples, but if we continue to add 360 around, we would get to the same spot. So we could do that again for like this one on the right. We could go around again and get back to the same thing, and we'd have another coterminal angle for these two. Now, if you want to be able to find a coterminal angle for anything, if you're given a 50 degrees or even something in radian measurements like pi over 6 for letter B, you can add either 360 or subtract 360 degrees. And if you're in radians, you can add 2 pi or minus 2 pi, because that will be once fully around the circle. Okay? So if I have 50 degrees and I add 360 to this, it gives me 410. But if I did 50 and subtracted 360 from that, so that would be the same thing as negative 310 degrees. So these both are considered coterminal angles. And so remember that you could have multiple answers. You could add 360 10 times, and you would have a coterminal angle, just very large coterminal angle. Okay? Pi over 6 is the same way. So if I add 2 pi to this, remember I got to make common denominators. So that would be the same thing as 12 over 6. So this would be 13 pi over 6. Okay? That would be one coterminal angle. If I wanted to do the same thing but subtracting, still have to make coterminal angles. So 12 pi over 6. So that gives me negative 11 pi over 6. Okay? So those are two options, and you can do multiple adding of 2 pi over and over again if you wanted a different coterminal angle. So there's an infinite amount of coterminal angles you could have. Okay? Example 4 wants us to be able to find an angle with measure between 0 and 360 that is coterminal with the angle measure of 1070 degrees in standard position. So if you have some angle and you want to get it in between 0 and 360 and find that coterminal angle, you need to take away 360s. Now if it's a negative number, so positive, you want to take away. If it's negative, that means you are in the negative position, so you need to add on to make it a greater number. So you need to add on rotations around the circle. So like this case, 1070 is greater than 360, so then I need to take away to get there. So then that gives me 710. Okay. Now I'll just continue to do this until I get to where I want to be. So I'll subtract another 360. That gives me 350. Oh, that looks like what I want. So 350 would be the coterminal angle of 1070 degrees. Okay? Have fun.